All right, seventh grade. We are on our second to last challenge of the quarter. This is challenge 11, Sumo Bot Starter. So the Sumo Bot concept kind of speaks to what it is exactly. If you're familiar with Sumo, but many of us don't know the basic concept of Sumo. So I'm going to talk a little bit about that. The basic concept of Sumo wrestling is to force your opponent out of a circle, right? There's some other rules if we're actually getting into sumo wrestling, like contact with the ground with any part of the body other than your feet is another way to eliminate a wrestler from a sumo competition. However, for us, for the purposes that we're gonna pursue here, the real concept is to push the other out of the ring. So sumo Lego Mindstorm Sumo Bot competitions are a real thing. It's not me making it up. It's not me talking crazy. This is an actual thing. There's a couple links at the top of the screen here. A couple links at the top of your Google slideshow for this assignment that are links to YouTube videos of sumo bot competition. So check it out. It's actually a pretty cool concept. At any rate, today what we're going to do is we're going to write a variation of a sumo bot program using the touch sensor. Excuse me. So the only sensor that we haven't programmed with that comes in our Lego Mindstorm kit is the touch sensor. So we've used the color sensor, we've used the infrared radiation sensor, the IR sensor. So we haven't used the touch sensor, and it's a pretty big piece of the puzzle. So we're going to write a program that will work with that. So the basic concept is our robot is going to have the touch sensor. The robot must drive forward until it makes contact with the other robot. So when it bumps into the other robot, that should be when the touch sensor is deployed. And when it runs into the second robot, it should use the grabber to lift the robot. Specifically, we're going to modify the grabber so that it's kind of a shovel piece instead of a grabber. So when it bumps into the robot, it should activate the grabber, right? Or the medium motor specifically. And then as it grabs and lifts, it should continue pushing the other bot. So after or once we lift, we should push the other robot out of the arena. So that's the basic concept. We want to make a program that makes our robot drive forward until it runs into something. Once it runs into something, it's going to lift and then continue to drive forward. That's what we're looking to do here. Now, there's a lot of ways to do this. I'm not going to say that there's one specific way. In fact, I'm going to show you a couple different ways that students from last quarter did. Once we've got some ideas, we're gonna go to work and write a program. So that's what we're looking at. So right here, I've got a blank, a new, clean, fresh programming window. But I'm going to start and show you a couple concepts that kids from last quarter used. So if we look here, here is one concept that's to me pretty succinct, pretty straightforward, and pretty simple, right? So we've got a loop here that's set up as a conditional loop on the touch sensor. When the touch sensor is touched, right? When it's pressed, then it's going to leave this loop, and this loop is just driving forward, right? So it drives forward. When it runs into something, it leaves the loop, and it's going to run the small motor or the medium motor. The medium motor will lift. And then we're going back into this loop, which is again pushing forward, and you can see this is going to be infinitely, right? So we're going to run into something, and when we run into something, that should deploy the touch sensor. Once it's deployed, it's going to lift, and once it's lifted, it's going to drive forward. That should do what we want it to do. This program should do the thing that we're looking for it to do. Again, pretty simple, pretty elegant way to make this happen. Here's another way, and I'll say this. The benefit of this particular program is that it could be a program that we use as the start and then that we build upon for future program, the last program that we're going to write, the Sumo program. So this one starts with just moving, and then it's going to use a switch block or an if-then-else statement to test if that touch sensor is deployed. If it is pressed, then it's going to run the lift. If it's not going to do anything, and then it's going to go back and touch and push some more, right? There is a little bit of a danger with this one in terms of we could burn out our medium motor if that touch sensor remains deployed once it's lifted, but it's not a huge concern for us right now because of how we've set up the touch sensor on the robot. So again, this program should do the same thing. This should work as well. I'm going to start and write this program, and then we'll talk about how you could think yourself through writing the other program as well. So let's get started. We're going to start with a loop. And again, we're going to set that loop up so that it's not unlimited, but rather is working on the touch sensor. And when we select touch sensor, we have to select the state, right? And what state do we want it to be in? Well, we don't want it release, we want it pressed. And we could, bumped would work as well, but specifically we're going to look at pressed, right? So bumped or pressed, one of those is going to be how we want to run this. I'll leave it as pressed. When the touch sensor is pressed, we want the program to leave this loop. So what is it we want to do in this loop? Well, quite simply, we just want to move forward, right? So I'll bring in a block and set it up as yours would be default. And this is one rotation forward. So basically your robot's going to go one rotation forward, check the touch sensor. One rotation forward, check the touch sensor. One rotation forward, check the touch sensor. When that touch sensor is depressed, then we'll leave this loop and we'll move on. Specifically, we want to move on to that medium motor because that's what runs our lifter, right? So we'll change the lifter to 2 rotations. If you remember that grip and lift with the gripper was 2 rotations, so this lift should also be 2 rotations, and we'll set it up as it would be for you on your program, which is, again, 50% power. Once we've lifted, we can't just stop because we want to get the robot out of the arena, so we need to introduce another loop. And we'll set this loop up as an infinite loop. And what do we want to do in that loop? Well, we just want to drive forward, right? So we'll do the same thing we did in that first loop. Again, just a regular move tank block right in there in that infinite loop. So now we're going to drive forward. Once we make contact with something, we're going to run the lifter. Once we've lifted, we're going to continue to push forward. This is a pretty sincere, pretty solid, excuse me, not sincere, pretty solid Sumo Start program, and it absolutely should do the thing that we want it to do, which is to drive, make contact, lift, and push. Okay? Let's look at another possibility. If you're interested, of course, you don't have to. If you're happy with this program and if you've written this program, take a screenshot of it, submit that screenshot, and you're good to go. But this program, the second program we're going to look at here, is a program that we could actually use and then build upon as we continue using or as we continue working with this Sumo concept. So we're going to bring in a loop, and then inside that loop, we're going to put a switch. Okay, and I'll set the switch up to look the way yours would look, and that's good. So in the loop, the first thing we want to do in our loop is we want to make sure that our robot is driving forward. So the first thing I'm going to do is I'm going to take a move tank, and I'm going to drop it in right before that switch. The switch is already set up on the touch sensor, which is good, because when that touch sensor is deployed, what do I want to do? I want to run my medium motor, and I'll set that up as yours would be. I'm sorry, I missed that with the large, excuse me, with the move tank. So that medium motor is set up to lift, but we got to make sure it's on 2 rotations because that's not 12 rotations. That'd be a problem. 2 rotations so that will lift completely and then continue to drive forward. Now in the X wing, we don't want anything. We don't need anything to happen here because if we don't have that touch sensor deployed or depressed, then we don't want to do anything, right? We only want to, when that touch sensor is depressed, we want to lift, and then we'll continue moving forward. This should do that, right? It should check the touch sensor. If it's depressed, it should lift. If it's not, it'll go back and move forward, and then check, and then move forward, and then check, and then move forward, and then check, and move forward, and check, and move forward. Continue to move forward as it even after it runs and runs into the robot and runs the lifter. So again, this program should do the job that we want it to do, which is good because it's fairly simple and fairly elegant. And again, we should be able to build on this program. Okay, so one way or another, you should have at this point a program written for your Sumo Start. Once you've got your program written, make sure you screenshot it and submit that screenshot in your exit ticket so that we can see your code and get your code onto that robot so that we can check out your code in a live robotic simulation of joy and happiness. That's it for this Sumo Start program. Can't wait to see what you wrote. Can't wait to see what you do for our final program of the quarter as well. And we'll see that in the not so distant future. See you soon.